Hello everyone. In this series, I'm going to explain about Linux device driver basics. So we'll start with what is device driver. So actually, device driver is a piece of code or software that manages and controls the device which is connected to the computer or embedded system. So normally we have a lot of devices connected to computer or embedded system like keyboard, mouse, display or pen drives and all. The code which controls these devices we call it as a device driver. So it's very simple as that. If you have any device, then we have a device driver for that device. In Linux, device driver has three main purposes. One is it has to directly talk to the hardware using various mechanisms. For example, if you are having I2C device or SPI device, then it has to directly talk to the I2C bus or SPI bus using various registers. Second one is device driver has to register the new hardware with the kernel. So kernel is a core heart of the OS. For a device driver also it's like a boss. You have to inform about the new device. That's what we call it as a device registration. So for example, if you are adding any new device, then you have to inform about the new device with the kernel using some kernel APIs. Third one is device driver also has to expose its interfaces and capabilities to the user space so that users can directly access the hardware using device file. Points I have put here for the reference. So device driver has three main purposes. One is it has to talk to the hardware using various mechanism. Second one is it has to talk to the rest of the kernel using kernel APIs. Third one is it has to talk to the user using device files. Why do we need a device driver? So without a device driver, the operating system will not know how to handle the device properly. For example, if you have any new hardware, we may need to do some pre-configurations before using the device, like setting some registers to receive the interrupt or GPIO configuration to set the normal pin to the I2C or SPA pins, similar to that. So when the device driver is loaded into the OS, we are doing all these configurations, and also it exposes the interfaces to the user space so that user space application can communicate with the hardware using device files. Here is the pictorial view of a device driver. If you see from the top, we have many user space programs are there. Then we have a device files. Device files I'm going to cover in the upcoming slides. Then we have a kernel space. Then finally we have a hardware. For example, if you have a ABC hardware, then you have to write a device driver for that particular ABC hardware. Device driver takes care of interacting with the hardware and export all the interfaces to the application. Then along with that, kernel's main job is it has to translate all user space open, read, write and IOCTL calls to the corresponding drivers open, read, write and IOCTL methods. In Linux, we have three types of device drivers. First one is character device drivers. Examples for character device drivers are keyboard, mouse, RTC, audio drivers, etc. Second one is block device drivers. Examples for block device drivers are flash drives, hard disks, etc. Third one is network device drivers. Examples for network device drivers are Ethernet, Wi-Fi, Bluetooth, etc. In this series, I am going to cover mostly on the character device drivers. What is character device drivers? Character device drivers are the drivers that accesses the data from device byte by byte, not as a chunk of data. In case of block drivers, data will be accessed as a chunk of data. For example, if you take any I2C or serial device, when you write 1 byte of data into that, it has directly goes to the device without any intermediate buffering involved. In case of block device drivers, there are many complex buffering mechanism involved in that. Examples of character drivers are keyboard, mouse, serial port, and sensors. As I mentioned earlier, in this slide, I'm going to explain about device files. Device files are the files through which only user space application will communicate with the hardware using these device files. Creation of this device file will be handled in the device driver using some special APIs. In Linux world, everything is a file. Even devices are accessed as a file in Linux system. These device files are special files which gets populated in slash dev directory at kernel boot time. There is a user space program called udev daemon, which is populating this slash dev entry with various device files. If you go to slash dev folder of your device, then you can able to list all your device files. In this first column, if you see letter start with the C, then it's a character device drivers. D is meant for a directory, and if you see letter start with the B, then it's a block device drivers. If you see here, all SDA and SDB are listing as a block device drivers. If you see the first column, it start with B. If you see all TTY drivers, all these are all called serial drivers. These are all start with letter C. These are character device drivers. Thank you for watching.